Let us start today's session with an activity. All of you take a paper, make two columns. In first column you write positive charge, in second negative charge. I'm going to show you 5 pictures. You have to segregate the things in that 5 pictures into positive charge as well as negative charge. In order to do this activity, you have to recall last week's topic, that is electrostatics, how the static electricity is produced. So here comes your pictures. Get start. I will show you each picture for 30 seconds. In that time limit, segregate the positive charge things and the negative charge things. The answers for this activity will be shown in the next class. In this video lecture, we are going to see about these 5 topics: conductors, insulators, induced charges, sparks, and flashes. Let's see one by one. Physics and electrical engineering, a conductor is an object or type of material that allows the flow of charge in one or more directions. Materials made up of metal are common electrical conductors. Electrical current is generated by the flow of negatively charged electrons and positive or negative ions in some cases. In order for current to flow, it is not necessary for one charged particle to travel from the machine producing the current to that consuming it. Instead, the charged particle simply needs to nudge its neighbor a finite amount, who will nudge its neighbor and on until a particle is nudged into the consumer, thus powering the machine. Essentially, what is occurring is a long chain of momentum transfer between mobile charge carriers. The Drude model of conduction
describes this process more rigorously. This momentum transfer model takes metal an ideal choice for a conductor. Metals characteristically possess a delocalized sea of electrons which gives the electrons enough mobility to collide and thus effect a momentum transfer. As discussed, electrons are the primary movers in metals. However, other devices such as cationic electrolyte of a battery or the mobile protons of the proton conductor of a fuel cell rely on positive charge carriers. Insulators are non-conducting materials with few mobile charges that supports only insignificant electric currents. Insulators are materials that inhibit the flow of electric current. The opposite of conductors, which allows electric particles to flow freely. Insulators are implemented in household items and electrical circuits as protection. Thermal insulation is similar, but it consists the flow of heat rather than electricity. Insulators. Insulators possess a high resistivity and low conductivity. Their atoms have tightly bound electrons that do not move throughout the material. Because the electrons are static and not freely roaming, a current cannot easily pass. In addition to protecting loss of current, insulators make an electric current more efficient by concentrating the flow. Metals are good conductors. Electrons in the outer layers of metal atoms are free to move from atom to atom. So if one end of a piece of metal is made positive, the electrons will attract towards it, and because they are free, they can move towards it. Static charge only builds upon insulators. These are materials that will not allow the flow of charged particles through them. Insulators are materials made from atoms that hold into their electrons very strongly. The voltage across an insulator has to be extremely high before an electron is giving enough energy to free itself and move through the material. Static charge won't develop on conductors unless they are isolated, because as soon as you put too many electrons in one place, they repel each other and spread out, reducing or eliminating the effect. On insulators, the charge cannot spread out, so you get noticeable effect. You can give metal objects static charge as long as whole object is insulated from the rest of the world so that charge cannot escape from it, even though the charge is spread evenly throughout the whole metal object. Good examples are the metal dome on a Van de Graaff generator and the annoying shocks that you get from cars. Semiconductors. Semiconductors have far fewer free electrons than metal, so do not conduct as well. However, if they are given energy, electrons are able to free themselves from their atoms and flow, which increases their ability to conduct. Some semiconductors are light sensitive, as the light energy is able to free the electrons. There are about 5 naturally occurring semiconductors. Induced charges. When a balloon is rubbed against the clothes, the negative electrons from the clothes get transferred to the balloon, making the balloon negatively charged. The balloon sticks. This is because the negative charge of the balloon repels some of the electrons in the wall or the ceiling away from the surface. This results in an overall positively charged surface, causing the negatively charged balloon to be attracted. The separated charges in the wall or ceiling are called induced charges. Static electricity in action. Rubbing a polythene strip on wool causes some of the outer electrons in the wool to move over to the polythene strip. As the polythene gains electrons, it becomes negatively charged. The wool loses electrons and left with a net positive charge. Only the negative charge electrons move. The positive protons remains fixed in the atom's nucleus. Rubbing materials to generate charge only works for insulated objects. Dangers of static electricity. Filling fuel on a plane can be very dangerous. A lot of friction is applied as fuel goes through the hose, meaning hose become charged. This could lead to a spark and then an explosion. To prevent this from happening, ground and earthing is used for wires that are lined with metal, which allows the charge to be conducted away. Another danger is lightning, which is also caused by static electricity. A cloud becomes charged when water droplets collide, the electrons get transferred. This means the cloud becomes negatively charged. This makes the positive charge on the floor come up. The clouds attracted to the ground and charges down as lightning. To prevent lightning damages, buildings like skyscrapers and churches, they have electricity conductors. They provide protection for building by providing the path of least resistance for the lightning into the earth. It does this making charge or lightning travels down the rod and into the earth where it will be dispersed safely. A static electricity spark is an electrostatic discharge (ESD) or sudden flow of electric current across an air gap, heating the air to high enough temperature to cause it to glow. The size of the spark depends on the separation of the sources of electrical charges and their potential differences in voltage. A spark may be only a few millimeters, several meters, or even kilometers in length.